Hello everyone. In preparation for the Calculus 1 course, we are still working on introductory topics. In this video, we will focus on factoring quadratics. Just a reminder that a quadratic is any expression whose form is ax squared plus bx plus c, where a, b, and c are real factors. In later sections, we'll discuss how a quadratic function behaves depending on the value of its parameters a, b, and c. Factoring will therefore give us insight about the graphical nature of quadratic functions. A quadratic expression can be factored by using a method that we refer to as the sum product method. Here are the steps of this method. Given a quadratic expression, ax squared plus bx plus c, our first step will be to find two numbers, m and n, whose product is equal to the product of a with c, and also have a sum that matches the value of b. In other words, m times n must equal a times c, and m plus n must also equal b. If such numbers exist, we're going to use them to rewrite ax squared plus bx plus c as ax squared plus mx plus nx plus c. You'll notice that we have converted bx into mx plus nx, and that is correct because one of our criteria was to make m plus n the equal of b. Afterwards, we'll factor by grouping, hoping that within each pair we'll have a common factor appearing. Here's an example where 2x squared minus 9x plus 10 is to be factored. A has a value of 2, minus 9 plays the role of b, and plus 10 is the value of c. According to our sum product method, we need to find two numbers, m and n, that will match the product of 2 with 10, that is, a with c, to give 20, and also add up to give the value of b, which is minus 9. By trial and error, you'll find that minus 4 and minus 5 accomplish both of these restrictions. Our second step is to break up minus 9x into minus 4x minus 5x. Therefore, we're using the m and the n values that we have just found. The quadratic 2x squared minus 4x minus 5x plus 10 has 4 terms, and then we will try to proceed by grouping, where in the first pair of terms, 2x is common. In the second pair of terms, 5 is common, but we'd prefer to factor out minus 5, given that that would leave an x minus 2 behind, which replicates the x minus 2 appearing from the first pair. X minus 2 being a common factor, we can proceed by simple factoring at this stage. X minus 2 is extracted, and 2x minus 5 is left behind. X minus 2 times 2x minus 5 is therefore the factored form of 2x squared minus 9x plus 10. In the second example, we'll look at how we can factor x squared minus 7x minus 30, and we'll discuss a shortcut that can be applied in situations like this one. You'll notice that a is not explicitly written, but can be assumed to be a 1. B is minus 7, C is minus 30. The sum product method requires that we find numbers m and n that will equal 1 times minus 30, and also match the value of b, which is minus 7. Again, by inspection, we'll find that minus 10 and 3 are numbers that can accomplish both of these criteria. Therefore, x squared minus 7x minus 30 can be rewritten as x squared minus 10x plus 3x minus 30. Then we can proceed by grouping, where x is recognized as a common factor of the first pair, and 3 is a factor of the second pair. And here's where we can tell that our procedure is actually going to work. We have created common x minus 10s within each term of the expression that we have. X minus 10 can be factored, leaving x plus 3. X minus 10, x plus 3 is the factored version of x squared minus 7x minus 30. Observe how in the last example, the numbers m and n that we found also reappeared with their sign in the factors, simply added to x. This will always be the case when the coefficient of the squared term, in other words, the a value, is 1. Looking back at what we did, x squared minus 7x minus 30 has an a value of 1. The sum product method required that we find two numbers, mn, whose product is minus 30 and whose sum is minus 7. Those numbers were minus 10 and 3. Now, because a is 1, a possible shortcut here is just to assume that we can apply minus 10 and plus 3 to simple x's to provide or to create the factors of x squared minus 7x minus 30. So x minus 10, x plus 3 is the factored form of x squared minus 7x minus 30, just like we found earlier. When relevant, identify situations where simple factoring can be done before moving on to other stages. So in this example, 3x to the power 7/3 plus 18x to the power 4/3 minus 81x to the power 1/3 is clearly not a quadratic. Therefore, the product sum or the sum product method is probably not what you would want to apply first. However, you may notice how 3 is a common factor of all 3 terms in this expression, and every one is a multiple of x to the 1/3. Therefore, 3x to the 1/3 is a common factor and can be extracted, and it leaves behind x squared plus 6x minus 27 that is quadratic, and therefore we can at least attempt the sum product method to factor it. Where x squared plus 6x minus 27 is concerned, a is 1, b is 6, and c is minus 27, and therefore the sum product method requires that we find m and n, whose product is minus 27. M and n must also add to agree with b, which is 6. Values that successfully match these criteria are m equals 9 and n equals minus 3, or the reverse. Obviously, m equals minus 3 and n equals 9 would also be acceptable. And we'll use 9 and minus 3 to factor the quadratic and then proceed by grouping. So in the first pair, x squared plus 9x, x was common. From the second pair, we've chosen to extract minus 3 to make an x plus 9. Repeat the one that came from the first term. X plus 9 is now a common factor and can be extracted, leaving x minus 3. Now, the techniques that we have described in this video may fail for certain quadratics. It is possible the numbers m and n are irrational and therefore really difficult to guess. In that case, the factored form can be obtained by completion of square or by using the quadratic formula. We've set up a different video or a supplementary video for these strategies.